Okay, we're going to be looking at how to construct, to solve for angle measures using trig. So take a look. We'll do a few of these problems. This one says construct triangle ABC with AB equals 2 inches, measure of angle B equals 90 degrees, and BC equals 1 inch. So I'm going to start with a 2-inch segment. It's going to be AB. So this is 2 inches. This will be A. This will be B. I follow it with a 90-degree angle at angle B. So that's going to be from here. And to make sure that it's lined up accurately. 90 degrees is this direction, so angle B will be in this direction, and the actual length of BC will be 1 inch. So from here I go 1 inch, so that is to the top. That means that this is 90 degrees, this is 2 inches, this is 1 inch, and this point represents C. So now I have my triangle. Okay, now I need to find the measure of angle C. So in other words, this will be theta. So I've got opposite and I've got adjacent. That means it's a tangent problem. So the tangent of C equals 2 over 1, which equals 2, just plain 2. So when I look at the trig table, for the tangent that equals 2, well, here it is, it goes. It's like somewhere right in there. So it's like between 63 and 64. I'll choose 63. So 63 degrees for angle C. AC is this one, so it's the hypotenuse of this triangle. So this can be A, this will be B, this will definitely be C. So it's 1 squared plus 2 squared equals AC squared. So that's 1 plus 4 equals AC squared. So 5 equals AC squared. AC will be the square root of 5 inches. Okay. Now I'm actually going to measure C to see what I get. I should get something very close to 63 degrees. And what I get is, it looks like 64 degrees, 63 and a half, which is pretty much what we noticed here actually. If you look it up, it was right between 63 and 64. So that's pretty accurate. I'm going to say 63, but it was right between 63 and 64. Now when I measure AC, it's going to be 2 and 1, 2, 3, 4 dashes. 4 dashes is 4/16 or 1/4. So 2 and 1/4 inches. Okay? So that's pretty close to the square root of 5 for reasons I'm not going to waste time explaining right now. All right, here goes another one. This one's slightly different because this one's going to be a compass construction. PQ is 3, QR is 4, PR is 5. As you can see, the longest one will be 5 PR. So I'm going to start with the longest one, which is 5 centimeters. Got to be careful how you start. Okay. There's P, there's R. So now PQ has to be 3. So I'm going to set my compass to 3. And that's going to be PQ. So I'm going to go from P, and somewhere along here, somewhere on this arc will be point Q. And QR has to be 4. So somewhere along this arc will be Q. The point where the two arcs intersect has to be point Q. So then I'm ready to construct my triangle. What we notice is that this being 3 centimeters, this being 4 centimeters, and this being 5 centimeters, is that this is a 3, 4, 5 triangle. So in a 3, 4, 5, A squared plus B squared equals C squared, right? Because obviously 3 squared plus 4 squared equals 5 squared. What that means is when the Pythagorean theorem comes out equal, the triangle is a right triangle. Therefore, the measure of angle Q has to be 90 degrees because the Pythagorean theorem came out equal. Now, if I want to solve for P, well, if P is my theta, I have a choice because I have all 3 sides. I can do tangent, I can do cosine, or I can do sine. I think I'm going to do sine this time just because I feel like it. So the opposite from P is 4, and the hypotenuse is 5. So if the sine of P is 4 over 5, that's 0.8. When I look up 0.8 in the sine column, the best thing I get is 53 degrees. So it's about 53. And then I'm totally allowed to just do the triangle sum theorem to estimate R. So if this is 53 and this is 90, this has to be 37. Very predictable. Now we'll actually measure to see how good the work really was. So when I measure angle P, what I get is 56 degrees, which is not great. It's off by 3 degrees, but it is acceptable. It's close enough. I think my mistake here is going to be at Q. Let's take a look here. Yeah, Q I've got here is only 87 degrees. So again, should be 90. It's close. It's not as close as I would like, but it's acceptable. And then R is going to be 39 degrees. So again, close, not perfect. But as you can see, this is a fairly good predictor of what we actually get. And I don't know, shouldn't be that hard. All right, that's all I'm going to show you for level 3. Take your time because there's basically 2 versions, and if you understand it, you should be good.